So one of the last things we talked about were greenhouse gases. Who can give me an example of a greenhouse gas? Carbon dioxide, what else? Examples of greenhouse gases. Okay, ozone, what else? Water vapor, methane, nitrous oxide. So remember, yep, N2O, nitrous oxide. So remember, methane comes from landfills. It also comes from livestock. It comes from waterlogged soils. Same thing with nitrous oxide. So what I wanted to do is I wanted to show you in Wisconsin, where are these greenhouse gas emitters? And so we're going to look at the greenhouse gases in Wisconsin, okay? And we're going to figure out who's polluting the most. So if I change this to their pollution relative to the amount of pollution that they emit. So darker, bigger green circles mean they're emitting more pollution. So you can see, where is there a lot of pollution being emitted? Kenosha, Milwaukee, okay? So what is this? Well, this is a power plant. This is a power plant. Now, this is for 2017. They shut down the Pleasant Prairie Power Plant in 2018, so this is not updated. We do not have this big green circle anymore. This is a power plant, okay? Power plant. Power plant. Now, some of the smaller things are landfills, okay, paper factories, etc. So you can actually go in and you can, this is CO2, you can change it so that it's going to show you methane, or so it's going to show you CFC production. And so this map actually gives you an estimate of all of those polluters. Of course, the map takes about 5 years to load, so I think I'm not going to wait for it. But you can get a general sense. Here we go. These are methane emitters, right? And so the top ones here are landfills, all these different landfills. And obviously, you're going to have more landfills where there's more people. So going back to our notes, you have this in your note packet. Yesterday, we talked about the IPCC. It's the Intergovernmental Panel on Climate Change. This is a committee that gets together and they do a report on climate change. And it's a whole bunch of scientists from all different countries that get together and do the report. And they predict what's going to happen. And they basically, it's like the State of the Union, but for the globe on climate change. One of the famous scientists that you need to know about who first studied the connection between CO2 and climate change was David Keeling. He's famous for this Keeling curve. This is from 1955 to 1995. Okay, notice in this short time span, CO2 is increasing significantly. Why do you think it goes up and down? Every year it goes up and goes down. Why? Why would the CO2 go up and down? Why is it sawtoothed? What gives off CO2? What natural stuff gives off CO2? Could be volcanoes, animals, right? And plants. Now you're like, Ms. Frankston, plants take in oxygen. Well, that's true. But guess what? They also give off some carbon dioxide because they do cellular respiration. Remember, cellular respiration is when we take sugar and we make energy. But in the process, we also make CO2. Both plants and animals do this. Okay? The difference is plants just have to take in CO2 in order to produce that sugar. Okay, and in the process they produce oxygen, but plants produce CO2 as well. So the reason it's sawtoothed, okay, is because the differences in photosynthesis in the different seasons, right? So in winter versus in summer, there's going to be different amounts of carbon dioxide emitted based on photosynthesis. All right, let's look at these graphs. Which country, so that's this first chart, has the highest CO2 emissions overall? Yeah, this is on the next page. Which country has the highest CO2 emissions overall? Yes, because of the seasons.
In the summer, is there less CO2?
Yes. So in the summer, the plants absorb that CO2, and in the winter, there's less of that being absorbed. So in the winter, it's going to be higher, and in the summer, it's going to be lower. So if we look at CO2 emissions, China and the US have the greatest amount of emissions overall. Okay? Then we get India, Russia, Japan, but look at how far ahead China and US are compared to all the rest of these. Now, per capita, what does per capita mean? Per person. So who has the highest emissions per person? US. So China has a ton of people, so it makes sense that they emit quite a bit. But if we divide by the number of people they have, China is all the way down here. So per person, we emit far more greenhouse gases than any other country. Since 1880, global temperatures have increased 0.8 degrees Celsius. This doesn't seem like a lot, a little less than 1 degree Celsius, same as 1.4 degrees Fahrenheit. But that can have a significant impact on organisms, especially like really sensitive organisms like coral. Okay, so the 10 warmest years on record since 1880. Okay, let's look at this graph. 1880 is down here. Hey, look, temperature. Anyone see a problem? It's increasing. The 10 warmest years on record since 1880, in the last 120 years, have all occurred between 1998 and 2013. That's kind of crazy. So there's no doubt that it's warming, okay? The problem is there's still people out there who don't fully understand climate change. So when we get a really cold winter, people will say, oh, well, climate change can't be real because it's really cold. Okay, again, the difference between weather and climate. Climate's long-term, over 10 years. One cold day, one cold winter doesn't make or disprove climate change. Okay, you can't really prove stuff, but you can disprove it. So let's look at this map. The darker red means the more it has warmed, okay, an increase in temperature. Blue means it's decreased in temperature. Which parts of the world have warmed the most? North, right? And especially the Arctic. So the northern hemisphere and the Arctic. And this is why you hear about the polar bears, because polar bears live in the northern regions. They do not live in Antarctica. So which one cooled the most? Antarctica. So this doesn't mean that the entire globe has to warm at the same exact rate or that all areas on the globe are warming. It just means overall, if we average it out, yeah, we're seeing more oranges and more warming, okay? So Antarctica has cooled the most. Yesterday we talked a little bit, reminder of positive and negative feedback. Remember, positive feedback increases the change, okay, or keeps the change going in that same direction. It doesn't mean that it causes an increase, it just means it makes the change bigger. So even if we're saying something is decreasing and decreasing and decreasing, that's still a positive feedback because it's amplifying or making the change bigger. The negative feedback reverses the change and brings it back to normal. So we'll go over a couple examples of those. I always refer to a positive feedback as like a snowball, right? It gets bigger as it rolls down a hill. It gets bigger and bigger and bigger. It's kind of that snowball effect. So some examples. The problem with the AP exam is they want you to know these examples, not necessarily these specific ones, but in terms of like permafrost and melting ice, they expect you to just know them, okay? They don't give you descriptions. They'll be like, oh, describe why ice melting in the Arctic and climate change is an example of a positive feedback loop. They're not going to give you an explanation and tell you and be like, oh, decide if this is positive or negative. Or even in the multiple choice that I've seen, they'll be like, oh, which is an example of a positive feedback loop? And they'll be like, ice in the Arctic. So they don't give you a description, which is kind of frustrating. But let's go through these examples. You'll see the same ones over and over, and they like to use those a lot on the test. So like these two are ones that they like to use a lot. So high temperatures increase decomposition in soil, releasing CO2 and increasing the temperature further. So what was my initial change was temperature increased, and then after, temperature increased more. So this would be positive because it's keep going in the same direction. Increases in CO2 stimulate plant growth, which cause more CO2 to be removed from the atmosphere. So this, we had CO2 increased, and then we had it decreased. So this would be negative. As Arctic regions become warmer and permafrost thaws, decomposition in the permafrost releases methane, causing the Arctic regions to warm further. Positive or negative? Positive, because it's warmer and it's continuing to warm. As the temperature increases, sea ice melts, causing more solar radiation to be absorbed by the oceans, melting even more sea ice. Positive. Okay? So we're going to talk about some effects with climate change. Don't worry, we'll have some breaks in here for some demos and stuff. But in terms of consequences, it's up to you how much you want to write of this. You have the consequences written there. If you want to write any of the bullet points underneath, it's up to you. So one of the first things we have is decline in polar ice at the North Pole. Is the ice at the North Pole in water or on land? It's in water, okay? So the ice at the poles are on water. Here's 1984. Here's 2012. There's a bit of a difference, right? Now, climate change impacts are not all bad, okay? So they think there might be increased access to oil and natural gas then, if we have more of that ice melting, and it will help us open up shipping lanes. Now, you might not be too excited about this, but some people are. Normally, we have to go in the summer all the way around this big ice sheet in the middle of the ocean. Now, in 2040, they're predicting it will be completely ice-free in the summer. And we can go all the way from Norway over here straight across to Alaska. Okay? Whereas before, to go from Norway to Alaska or to go from Canada to Alaska, you had to go all the way around. So some people are getting excited about that. Yes, so we can burn more fossil fuel. Well, I mean, it is shorter here, so we might burn less, but yeah, yes, exactly. Okay, let's look at Antarctica. Antarctica ice changes over time. This is just in the same year. This is just from seasonal ice variation, so in the summer versus the winter, okay? Antarctica ice has increased in total area, meaning it's gotten bigger. But the mass, its thickness, has decreased. So even though it's not experiencing as drastic shrinking as the Arctic, it's still shrinking. This is the ice mass in Antarctica from 2003 to 2009. In 6 years, this was the mass change in gigatons. What's the prefix giga? Which one is it? Billion. Okay, now here's the problem. If we're adding a whole bunch of fresh water in the oceans, it's going to disrupt that thermohaline circulation. Thermohaline, what two words are here? Salt and heat, right? This is what I always refer to as like the Finding Nemo. I forget, what's the turtle's name? Okay, anyway. Anyway, you remember when they're riding on the little current? Okay. So this is what I refer to as the Finding Nemo current, right? The guys that are riding on the ocean current. And the current is important because it's mixing the salt water and it's mixing the water on the bottom of the ocean with the water on the top. It's also important because it's distributing heat, and they actually think that this is going to shut down because if we add a whole bunch of this fresh water into the oceans, there's not going to be enough of a difference in salt concentrations to influence this circulation pattern, or to basically to keep it going. All right, melting glaciers. Here's your activity. Okay, you have pictures of glaciers. I want you to match them up on your desk. Okay, so with melting glaciers, melting glaciers leave some people without a water supply because they depend on those glaciers in order to get water, drinking water. And if those glaciers are completely gone, then they're not going to have drinking water. Okay, so it's kind of up to you what you write down on these. Obviously, you have the effect, melting glaciers, and then we have some additional effects as well that you can choose to write down or not. So we have melting glaciers. We did the activity. If you only write down one thing from climate change, you need to know about permafrost. Okay? So permafrost is permanently frozen ground in the Arctic. Okay? And it stays permanently frozen all year round. When this melts, it's a problem because frozen ground is really hard. When it melts, it does not stay hard. It becomes really soft. So you see a lot of pictures like this where people and their homes are actually sinking into the ground because it basically turns into like a mud pit. No. It gets too warm in Wisconsin for us to have permafrost. So the big thing that you need to know about permafrost is right here. When it warms up and it melts, it increases or allows decomposition to happen. It's permanently frozen. Okay, so why do you put your dead goldfish named Fido in the freezer if you can't bury him? Because he's not going to decompose, right? Sounds very personal. So the poor people who are listening to this, the soil, okay, when it starts to warm up is when that decomposition happens. That's when we can get the mold and the decomposition, and it's going to release methane from that. So the permafrost is a big part of methane production, right? Producing methane, which is that greenhouse gas. Okay, if we look up here, what's happening to the water in the demo?
It's going up.
Going up, right? So warm water expands. It'll go all the way
I
up.
don't know for sure.
Okay. Well, we'll check on it in a minute.
Trying to escape the situation.
Miss Grayson.
Yeah.
Remember when we guess
What?
scientists found worms from like 11,000 years ago in like permafrost?
That is crazy.
They're like, why?
I don't know, bro. Miss Grayson, you're
All right, the one thing I would like you to write down, do you need to know the inches? No, I need you to write down this. So as water in the oceans becomes warmer, it expands. Charlotte, can you tell yet if it's increasing at all?
Well, you didn't mark anything.
I didn't mark anything.
Oh, it's going really fast. It's going fast.
yeah, so, one drop. One drop.
So sea levels have risen 9 inches. They're expected to rise 7 to 23 more inches. Why is that a big range? Well, it depends on what we actually end up doing. If sea levels rise significantly, look what's going to happen to Florida. Oh, it's not looking so hot. New Orleans? Here's the percentage of people who will be underwater in each country. Oh, hey, 10 to 25% of the U.S. population will be underwater. If the sea level... You only needed to write as water becomes warmer, it expands. Some of these island nations are actually almost already underwater, or they will be completely underwater. Some of these coastal nations, if the temperature continues to increase. So, for example, the Netherlands. Oh yeah, they're below sea level. All right, coral bleaching.
We gotta go soon.
There we go.
Yeah. I didn't know. I don't know what time we get out. No, I didn't know what time we get out.
Oh, turn it off. Okay, so again, the only thing you needed to write from this slide is this. You didn't need to write any of the statistics. I mean, if you wanted to, that's fine. There is a blank spot. You know what coral bleaching is, but in case you forgot, okay, coral bleaching is when corals eject their algae. Remember, they have a symbiotic relationship with algae, and it's caused by pollution and warming oceans. We saw that corals are really sensitive to temperature increases, and so even a tiny amount of temperature increase, like 0.5 degrees, can cause coral to become stressed enough. Anyone want to go to the Great Barrier Reef? Guess what? It's going to be gone in about 25 years. So if you want to go, better go now.
We gotta go, guys.
Field trip.
Last day of senior. Oh my God.
Tomorrow we're going to look at ocean acidification. We'll do a lab. That's why we kind of have to get through these crappy notes today. On ocean acidification. So the ocean is becoming more acidic. Carbon dioxide, which is in our atmosphere, is actually a weak acid. So when it dissolves in the water, it makes the oceans more acidic. And that can be a problem for some of the marine life, because if we have too much acid in the ocean, they can't build their shells. So all of your nice little shell organisms like lobsters and crabs and snails.
Are we just screwed in this question?
Pretty much. I would like to.
They're not like horrible, but like I only get them if someone else does. Okay, I'll eat them. Like I'm not gonna order like a whole thing. Yeah. And I talked to you because we're talking about oysters.
Was anybody here talking about oysters?
We were in the full conversation.
That's my bad.
Yeah, it was.
Alright, can we talk about oysters? Yeah, can we go to the aquarium?
We will see.
Wait, is that an actual thing?
I don't know.
We will go.
I will give
We will go.
$25.
We will go, guys. We should go visit Sri
Let's go to the shed.
Just to see how
Yes.
fast.
Let's bring Sylvie some
We need to
Like,
see
let's
environmental
go.
effects.
We've gone on a field trip at like Greenland. No,
I've
say,
never-
Wanna
say
talk
we're gonna
about
write down
pollution?
statistics on what happened to each fish at that shed.
I'm not doing that. Just letting you guys know.
All right, here's what happens in the ocean that we'll talk more about tomorrow. But as the CO2 goes into the ocean, it creates carbonic acid, which we'll talk about. And basically, it makes it harder for these organisms to make their shells. And so what we end up seeing is organisms with deformed shells, or organisms that are unable to make those shells. And that includes coral as well. Okay, so a lot of these organisms are affected by the increased amount of carbon dioxide. All right, we're almost done. So we talked about organisms changing, right, in behavior. So if it's too warm, they're going to migrate north. We talked about their migrating patterns. Okay, so increase in growing season in the northern hemisphere. What does that mean? We can grow plants longer. Why? Because our winters aren't as harsh. Okay, that would be good for agriculture, right? For CO2, no, because plants take in CO2, more CO2 than they release. So plants are going to flower earlier, birds breed earlier, insects emerge earlier, and then organisms migrate north. We looked at this, where the birds are migrating. That's because it's more like their native habitat where it's cooler. We're going to get more heat waves. You already know this. Heat waves cause increased energy demand. When I lived in St. Louis, I woke up and it was 90 degrees every day in the summer, and it would get to be 110. How much am I going to run my air conditioner? Pretty much nonstop. There were quite a few blackouts because so many people were running their air conditioners that the power plants could not keep up. Okay? So warming temperatures, though, mean we might have new areas for agriculture that were originally too cold. So that could be a good thing. But the problem is we're going to get a lot of pests expanding because the freezing temperatures are what kill them. And if we don't have as many freezing temperatures, we're going to have more pests. And lastly, some areas are going to get more rain, some will get less rain. We're going to see an increase in extreme weather events, floods, hurricanes, tornadoes, because warmer air holds more water vapor. And if we have more water vapor in the air, then we can have more intense storms. So this is just the frequency of North Atlantic tropical storms from 1925 to 2005. Notice how much they've increased, okay? So average number of named storms per year.